All right, we're back here with this equation here. We have this system which is not in a nice graphable form, not in slope-intercept form, but we looked at it and we found out that both these equations, even though they looked very different, ended up actually being the exact same thing. So this is an infinite set. So we're going to take a look at what it looks like if I do substitution or elimination method in our part 2 of this. And again, don't forget, you can follow me on Instagram, YouTube, and TikTok, YouWantAlgebra. And these are found in the systems of equations. I'm going to put this one in the elimination method section this time. This part 1 was done, and that's in the graphing section. All right, so let's take a look at what happens with the substitution method and elimination when we have infinite solutions and what it looks like. So if I'm using the substitution method, I want to substitute for one of the variables. So I'm actually seeing that there is a positive 1 in front of the x, or it's not written there, but it's there. So we're going to actually rearrange that equation because that's the easiest to get x by itself. So we're going to subtract 2y to move it to the other side, and now you're going to be left with x is equal to negative 2y plus 4. Now some people ask me, can you put 4 plus a negative 2 or 4 minus 2y? That's fine. You can totally do that. This is just my method, and that's okay. So now I know that the x is this. I just boxed in. So what I'm going to do is right here, I'm going to replace it in the second equation right where x is. So we are going to have 2, and then in parentheses, instead of x, we're going to have this whole thing I just put a box around, and then we'll distribute that in a minute, plus the 4y is equal to 8. 2 times negative 2y is going to give me negative 4y. 2 times 4 is going to give me 8. And then we've got the rest of this. And then we're going to take a look. And right here, we see the 4y and the negative 4y. Those are going to cancel each other out, completely leaving with 0. And what's left is 8 over here on this side, 8 over there on that side. So because these are exactly the same on both sides, our x's are wiped away completely. I can identify that this is going to be an infinite solution set. So that would be what I would write. So in the substitution method, that's what it looks like. And now we're going to take a look at it, what happens with the elimination method. Now elimination, you want to eliminate something, the first thing we check is to make sure that the x's are on top of each other, the y's are on top of each other, and the constants are on top of each other. Since they are, we're going to now figure out what item do I want to eliminate. So make it easy for yourself. I am going to just multiply the whole top by a negative 2. So we're going to multiply the entire top by a negative 2. And by doing that, what is going to happen is it's going to make the x's go away, because the negative 2 times a positive x, I'm just going to write it down here, gives me a negative 2x. So now I have the opposite pair there. Negative 2 times a positive 2y is going to give me a negative 4y. And then here, negative 2 times a positive 4 is going to give me a negative 8. Now what happens when I go to add these together, 2x plus a negative 2x, those cancel. 4y plus a negative 4y, well, those cancel as well. That leaves me with nothing over here. And then 8 plus a negative 8 cancels over here. And you end up with 0 equaling 0. This is infinite solutions, and you are good to go with all 3 methods. Again, if you want to follow me, Instagram, YouTube, and TikTok, at YouWantAlgebra. This second part video will be in the elimination of systems of equations section.